In June 1991, one of the most violent volcanic eruptions in modern history tore through a mountain in the Philippines that nobody had been watching. There were no warning systems, no evacuation plans, and nearly 2 million people living nearby believed it was completely harmless. Then, on June 15th, the mountain exploded. The sky went dark, entire towns disappeared under ash, and what should have become one of the deadliest volcanic disasters in modern history somehow wasn't. Because in less than 10 weeks, scientists and officials pulled off something almost impossible. So, how do you evacuate millions from a volcano no one even knew was dangerous? That answer starts not with the eruption itself, but with a woman who, on a morning in early April 1991, walked into a government building in Manila with a group of villagers behind her and told the scientists inside that something was wrong with the mountain. Before you continue, if you're fascinated by the science of survival at extreme altitude, be sure to check out our high-altitude survival guide linked in the description. Her name was Sister Emma Fondavilla, and she had been living among the Aita people on the slopes of Mount Pinatubo for years. A Franciscan missionary with a science background, she understood what the community she lived with was experiencing, and she understood that nobody in Manila was going to hear about it unless she made the trip herself. She did not have an appointment. She did not have data. What she had were the observations of a community that had been living on Pinatubo's slopes for generations and had started noticing things they could not explain. The earthquakes had been building since March, small, frequent, and persistent in a way the Aita had never felt before. The sulfur smell in the forests was new. The fish had disappeared from the mountain streams. One community leader would later describe what those weeks felt like in 4 words. The mountain felt wrong. The scientists at FIVOLCs listened, and what Sister Emma didn't know as she sat across from them, what none of them fully understood yet, was that the mountain she was describing had never appeared on any volcanic hazard registry, had never been studied by a modern volcanologist, and had not erupted in so long that there was no living record of what it was capable of. 9 miles from its base, inside Clark Air Base, 15,000 American military personnel and their families were going about their lives with no idea that anything was happening on the mountain behind them. A few days after Sister Emma's visit, on April 2nd, 1991, the mountain answered for itself. A 1.5-kilometer fissure cracked open on Pinatubo's north slope, releasing steam and sulfur from a line of 9 thermal vents, the first visible surface activity the volcano had produced in 540 years. Dr. Raimundo Punongbayan, director of FIVOLCs, saw the reports and understood the position his agency was in. A volcano had just announced itself, and FIVOLCs had almost nothing to work with. No seismic baseline, no gas measurements, no modern eruption record, no hazard maps of the surrounding valleys. The mountain had been silent so long that studying it had simply never come up. He called the one person he knew could help. Chris Newhall was a USGS volcanologist who had spent his career at the sharp end of volcanic crises across Southeast Asia and Central America. He had co-developed the Volcanic Explosivity Index, the scale scientists use to measure and compare the magnitude of eruptions across geological time. He had seen what happens when a sleeping stratovolcano wakes up, and when Punongbayan described what Pinatubo was doing, Newhall understood 2 things simultaneously. This was serious, and time was the one thing nobody could get more of. Within 3 weeks, Newhall had assembled the USGS Volcano Disaster Assistance Program, a rapid response unit built exactly for this kind of scenario, and was on the ground at Clark. The team set up in empty bedrooms inside the base, working from cots and folding tables, sending faxes, consulting textbooks, reading seismograph paper by hand, while 15,000 military personnel went about their day outside. They placed instruments across the mountain's flanks, seismometers to detect subsurface earthquakes, tilt meters to measure ground deformation, gas monitors to track what the volcano was releasing. The sulfur dioxide readings came back in the thousands of tons per day, which meant one thing: fresh magma, already on the move. When the team mapped the surrounding landscape, the valleys, the ridgelines, the towns built along the river systems, they found something that made the urgency sharper. The entire terrain around Pinatubo was essentially constructed from what its previous eruptions had deposited. People had built their lives on top of the wreckage of the last time this happened. And the geological record suggested this volcano had a pattern: catastrophic eruptions, roughly 1,000 years apart. The last one had been 540 years ago. Having the data was one thing. Getting anyone to act on it was something else entirely. The evidence for a major eruption was compelling. It was not, however, certain. Volcanoes had escalated before and gone quiet. Seismic swarms had tapered off. The dataset Newhall's team had built was only 10 weeks old, from a volcano with no modern eruption history, and it was being presented to institutions that had every practical reason to want a different answer. For the U.S. Air Force commanders at Clark, the calculus was not irrational. It was a question of consequences on both sides. Moving 15,000 people, grounding aircraft, and shutting down one of the most strategically significant installations in the Pacific was not a decision you made lightly on the word of a team that had been on the ground for 6 weeks. If the forecast proved wrong, careers would end. The professional damage would be lasting and real. At one point, the team showed military officials video footage of pyroclastic flows from other eruptions, not to frighten them, but to make the abstraction visible: speed, distance, what they left behind. For some of the people in those rooms, it was the first time the numbers on the hazard maps became something they could actually picture. Rick Hoblit, one of the VDAP volcanologists, would later reflect on those weeks with characteristic restraint. If the volcano had not performed as predicted, he told a journalist, it would not have been very good for any of their careers. Newhall put it differently. He described being a scientist trained to qualify every claim, forced to speak with a level of certainty he wasn't entirely comfortable with, because the alternative was that nobody moved, and he already knew what that looked like. Then the mountain stopped waiting. On June 6th, the seismometers registered something the team had been watching for. The earthquake swarms were getting shallower. Day by day, the fracturing was moving closer to the surface, which meant the magma was too. The tilt meters showed the upper flanks of the volcano beginning to swell outward. On June 7th, a small explosion sent ash 7 kilometers into the sky, Pinatubo's first eruption in 540 years. And on that same day, the sulfur dioxide readings collapsed. From thousands of tons per day, they fell to around 250. To anyone outside volcanology, that might have looked like relief. The volcano calming, the crisis passing. To the scientists, it was the most alarming reading they had seen. A sharp drop in SO2 at this stage of an eruption sequence typically means the rising magma has become thick and viscous enough to seal the conduits it had been venting through. The gas pressure that had been escaping is now trapped. The volcano is not calming down, it is sealing itself shut, loading pressure behind a plug that will eventually give way. The lava dome that began pushing through the summit vent on June 7th and 8th confirmed it. Solid, degassed magma being forced to the surface by the pressure building beneath it. The magma had arrived. The question was no longer whether Pinatubo would erupt. On June 9th, PIVOX raised the alert to its highest level. Eruption imminent. The Clark Air Base evacuation began before sunrise on June 10th. 15,000 non-essential personnel, contractors, and family members were loaded into road convoys and moved to Subic Bay Naval Station on the coast, 25 miles to the south. Aircraft had been flown out in the days before. By nightfall, the installation that had anchored American military power in the Pacific for nearly a century stood empty. The operation had a name, Fiery Vigil, and it had been completed in a single day. The civilian evacuation expanded alongside it. By the time June 15th arrived, more than 65,000 people had been moved from the highest risk zones, a scale that had never before been attempted ahead of a volcanic eruption. The scientists had made their argument. Enough people had listened. For the Aeta, however, the evacuation was the beginning of a different kind of loss. The 20,000 Aeta people relocated from Pinatubo's slopes were hunters and forest people, with deep generational knowledge of the mountain they were being asked to leave behind. The lowland camps they were moved to were overcrowded, under-resourced, and had been built for an emergency, not for the people who would end up living in them for years. Some Aeta refused to go at all, retreating instead to caves on the upper slopes. An unknown number did not survive the eruption. Those who reached the camp survived June 15th, and in the weeks that followed, approximately 500 Ayeta children died in those same camps from measles, diarrhea, and bronchopneumonia, diseases that spread in the conditions the camps produced and which the official death toll from Pinatubo has never consistently included. The evacuation saved tens of thousands of lives and, at its margins, ended a world. June 12th. The first major eruption arrived at 8:51 on the morning of June 12th. The seismometers caught it milliseconds before it was visible, a massive spike in ground motion as the pressure finally broke through the sealed dome. The eruption column climbed 19 kilometers. Pyroclastic flows swept down the western valleys. Somewhere on the other side of the base, the Clark evacuation had been completed 48 hours earlier. A small team of volcanologists had stayed behind at a monitoring post to keep taking readings. As one flow advanced toward their building, the team pressed against the back wall of a cinder block structure with no vehicle, no route, and nowhere to go. The flow stopped before it reached them. Over the following 72 hours, eruptions came at intervals, each one larger than the last, each one testing the forecast against what the mountain was actually doing. The team stayed. They kept transmitting. On the morning of June 15th, their readings went off their scales. At 1:42 in the afternoon on June 15th, 1991, Mount Pinatubo produced the largest volcanic eruption recorded by modern instruments in the 20th century, roughly 10 times more powerful than the 1980 eruption of Mount St. Helens, which the world had considered its benchmark for a major eruption until that afternoon. The column punched 40 kilometers into the stratosphere. Pyroclastic flows, avalanches of superheated gas and rock, moving at 700 kilometers per hour, descended every drainage on the mountain simultaneously, traveling 16 kilometers from the summit, overtopping ridgelines that had been measured, mapped, and expected to hold. Valley floors disappeared under 200 meters of material. The sky above central Luzon went black. On the same afternoon, Typhoon Yunya made landfall on the island. The two events were entirely unrelated. They simply arrived together, on the same island, on the same day. But their coincidence compounded the destruction in ways neither would have produced alone. The typhoon's rainfall soaked the falling ash, turning it from powder into weight, dense, saturated, concrete-heavy, accumulating on every roof across the region. Structures that might have survived dry ash loading collapsed under the sodden mass. Across dozens of separate survivor testimonies, people described the same feeling in almost identical words. They were certain it was the end of the world. When the final count came in, 847 people had died, and approximately 90% of those deaths were caused not by the pyroclastic flows, but by roofs collapsing under ash that a typhoon had made heavier. USGS and FIVOLCs estimate the evacuation saved between 5,000 and 20,000 lives. The lower bound of that range is an entire city's worth of people who were not in those valleys because a small team of scientists had made an argument they were not sure they could prove, to people who did not want to hear it, and had somehow been believed in time. What most people who know the story of Pinatubo have never heard is what the eruption did to the planet, not the ground below, but the atmosphere above. In the hours of June 15th, the eruption injected approximately 20 million tons of sulfur dioxide directly into the stratosphere. To put that number in context, every power plant, every car, every industrial facility on Earth combined produces roughly 100 million tons of SO2 per year. Pinatubo released a fifth of that in a single afternoon, shot directly into the layer of atmosphere that sits above all weather and all wind patterns that might otherwise have dispersed it quickly. The SO2 reacted with water vapor to form sulfate aerosols, microscopic particles that don't fall back to Earth, but drift on stratospheric wind currents for years. Pinatubo's aerosol clouds circled the entire planet in 3 weeks. Within a year, it had spread across both hemispheres, a consequence of the volcano's near-equatorial position, placing its emissions into the one band of atmosphere that distributes material globally rather than regionally. The aerosol layer acted like a partial shade drawn across the sun, reflecting incoming solar radiation back into space before it could warm the surface below. Global average temperatures dropped by approximately 0.5 degrees Celsius over the following 2 years. And to understand what that means, consider that the entire measured warming of the 20th century amounted to roughly 0.6 degrees total. Pinatubo, in one afternoon, temporarily unwound most of a century's worth of accumulated heat. The global temperature curve, which had been rising steadily through the late 1980s, flatlined for 2 years and then resumed as if the mountain had simply pressed pause. The aerosols also accelerated ozone destruction. The sulfuric acid particles provided surfaces on which chlorine compounds, already present in the stratosphere from industrial pollution, could break down ozone molecules far more efficiently than they could on their own. Ozone concentrations over the mid-latitudes fell to the lowest levels ever recorded. The ozone hole over Antarctica in 1992 was the largest that had been measured to that point. And then the question that Pinatubo quietly posed to the scientific community and has never fully gone away. If a single unmonitored volcano, identified only because a missionary made a trip to Manila, could cool the planet by half a degree for 2 years, could humans replicate that deliberately? Could aircraft inject controlled quantities of sulfate aerosols into the stratosphere to offset the warming that industrial emissions are producing? The concept has a name: stratospheric aerosol injection, and it is today one of the most seriously debated proposals in climate science. The entire body of real-world evidence underpinning that debate comes from the 2 years of atmospheric data collected after June 15, 1991. The mountain nobody thought to watch gave science the data it needed to ask whether humanity might one day try to control the temperature of its own planet. Clark Air Base came out of June 15th, buried under 2 feet of volcanic ash. Engineers spent the summer assessing what remained of the runways, hangars, and infrastructure. On July 12th, the Secretary of the Air Force made it official. The United States would not be going back. The American flag was lowered for the last time on November 26, 1991, by the personnel who had stayed through the months of cleanup, the people who came to be called the Ash Warriors. 90 years of American military presence at Clark Air Base ended not by a treaty, not by a political decision, but by a Tuesday afternoon in June. The base was handed to the Philippine government and eventually became Clark International Airport and the Clark Freeport Zone, a city that grew up on the footprint of the one the volcano had ended. The lahars came with every rainy season for more than a decade. The eruption had deposited enormous quantities of loose volcanic material across Pinatubo's flanks, and each monsoon and typhoon season remobilized it, sending debris-laden flows down the river valleys, burying farmland, collapsing bridges, and flooding towns that had survived June 15th intact. The engineering response, dikes and sediment dams costing billions of pesos, was repeatedly overwhelmed. Communities were forced to evacuate again from the same places they had already evacuated to once before. For the Ayeta, the emergency camps of 1991 became home in the worst sense of the word, not by choice, but by the absence of any other option. The mountain was gone. The summit had collapsed inward during the June 15th eruption, taking with it the forests, the hunting grounds, the cultivation systems, and the ecological knowledge that had organized Ayeta life for centuries. The resettlement program gave each displaced family a 150 square meter lot. It had no mechanism for returning what the lot was meant to replace. As of 2011, Ayeta communities displaced in 1991 were still living in evacuation centers, still threatened each typhoon season by lahar flows, still waiting on a recovery that the international success story of Pinatubo had never been designed to include. 35 years later, people paid a hike to the top of it. Where the summit once stood, there is now a crater lake of striking emerald color, and tour operators run morning departures from Manila to see it. The monitoring network that watches the volcano today, 9 stations around the clock, is a direct consequence of what wasn't there in April 1991, when the first warning came not from any instrument but from a community that felt the ground moving and a woman who knew to take that seriously. The material Pinatubo deposited on June 15, 1991, is still moving through the landscape, slowly toward the sea. Whether the full story of what happened here is a success depends entirely on whose survival you're counting, and how far into the aftermath you're willing to look. Before you go, Don't forget to check out the High Altitude Survival Guide in the description below. Subscribe if this is the kind of story you came here for. And tell us in the comments, which disaster, expedition, or mountain should we investigate next?